Hello class, today we're going to be talking about solving systems of equations using algebra. So remember, a system of equations is two linear equations comprised of two related variables. So the solution to a system of equations is where our two lines cross. So we're looking where the x and the y are going to be the same in both of those equations. And that is a terrible writing. Alright, so the first way we are going to be talking about solving systems algebraically is by using substitution. So remember, a substitution is when we're replacing something. So this is best when one variable is already solved for. We can do it other ways. We'll talk about it using other ways, but it's kind of easiest when it's already set up like this. Alright, so our first step is to select one equation and solve for one of the variables. So we're going to solve for either x or y in one equation. Or if there's one that it's already solved for, we're going to choose that one. Alright, our second step is to substitute that value into the other equation. So whatever we end up with, we're going to take that whole expression and put it in wherever we see the x or y in the other equation. Alright, so then whenever we do that, we can solve down, and the result is going to be with one variable. And we're going to solve for that variable. After we finish that again, we are going to substitute again into one of the original equations. So we want to go back to one of those original equations just in case we messed up somewhere. Alright, and then our very last step, once we figure out what our x and our y is going to be, we're going to write the solution in point form. So just as our xy coordinate. Alright, so let's go ahead and practice on this a little bit. Move this up. Alright, so we have two equations here. We have negative 2x plus y equals negative 2, and 3x minus y equals 4. So when we're solving equations and we're trying to get it down to one variable, we want to choose the easiest thing to solve for. In this case, the easiest thing to solve for is going to be anything that is positive and with a 1 in front of it. So we're going to take our top equation and solve for y. So when we take that top equation and solve for y, we need to move the 2x over, so we're going to add 2x to both sides. So negative 2x plus 2x is going to disappear. That becomes a 0. We're left with a y. And we can't combine the 2 and the 2x because they are not like terms. So we end up with y equals 2x minus 2. Alright, our second step is to take all of this and plug it into y in the original or in the other equation. So in this 3x. So I'm just going to take that 3x and nothing is changing with that. I'm going to put the minus, nothing is changing there. The only thing that's changing is instead of y, I'm going to put 2x minus 2 there. because that's what y equals. It's the same thing. And in this equation, we equal 4. So now we can solve this out. So remember, we need to get rid of parentheses. To get rid of parentheses, we're going to distribute what's in front. Since we just have that minus there, we're going to distribute the -1. So we end up with 3x minus 2x plus 2 equals 4. All right, and then we need to solve for x here. So we're going to combine like terms. 3x minus 2x is x. And the rest I'm just going to bring down. So I end up with x plus 2 is equal to 4. Now we can use inverse operations to get rid of the 2. So minus 2 on both sides. And we get x equals 2. All right, so one more thing we need to do. We need to take this x equals 2 and plug it into one of the original equations. You can choose whichever one you want. So I'm going to go with that top one just because we have that positive y there. So I'm going to replace x with 2. Negative 2 times 2 is a -4. And then we add 4 to both sides. And then we end up with y equals 6. So on this problem, our solution is 2, 6. All right, so I made a mistake here. Our answer is not 2, 6. I left something out when I was working this. I lost my negative. So we have -2 plus 4 instead of 2 plus 4. So that changes us to have y equals 2. So the solution to our system is not 2, 6, but it is 2, 2. I am sorry about that. I don't know if the negative didn't write or if I just left it out. All right, pause the video here and take a minute and try to solve this next equation. All right, guys, so you might have some work that looks similar to mine. You do want to come up with the answer -4, 3. So I chose the top equation and to solve for x first, so you get this. We plugged it in, and we solve that out, and we get y equals 3. I plugged that into our top equation again, so x plus 2 times 3 equals 2. Solve for x and got that -4. Your problem may look slightly different than mine. That's okay, because we may have chosen to solve it different ways. Alright guys, so we have talked about having some special cases when it comes to these systems of equations. We're going to see what that looks like when we're solving them out algebraically. So I'm going to take that top equation, because we have an x by itself, and then solve for x. So we get x equals 2y plus 3. Plugging that into our other equation. So we get 4y plus 3, or plus 6 when we distribute, minus 4y is equal to 6. We combine our like terms. Those are going to disappear. We no longer have a variable. When something like this happens, when our variable disappears, that means these are the same lines. So that means that we have infinite solutions. So we have the same line, so they are always going to be touching each other. Our other special case, we see it over here on this other side. I'm going to go ahead and solve for x on that top one because it's the only thing that doesn't have a number with it. So start by subtracting 2y. Don't forget to bring that negative x down. So since we have that negative 1 in front of x, we need to divide everything by negative 1. So we get x equals 2y minus 3. So taking that and plugging it into our other equation, we get 2 times 2y minus 3 minus 4y is equal to 3. We distribute. 4y minus 6 minus 4y equals 3. Our 4y's are canceling out. We're left with negative 6 equals 3. That is not true. So when it is not true, that means we have parallel lines and we're going to have no solution. Those lines never cross each other. So if you get true, it's going to be infinite. If you get false, it is none. Alright guys, take just a minute, pause the video here, and work on those practice problems down below. I will give you the answers in just a minute when you hit play. Alright, so these are the answers that you should have gotten. If you got any of them wrong, please ask questions or see if you can figure out what went wrong. Okay, the other way of solving a system of equations algebraically is by elimination. So again, up here at the top, we have two equations that are related or comprised of two related variables, and the solution is where the two lines cross. Alright, when we are working with elimination, it is best when they are set up in standard form. Our ax plus by is equal to c. So our steps for this, we want to line up all the variables in constants. So that means we want all the x's to be on top of each other, the y's to be on top of each other, and the just numbers to be on top of each other also. So then we want to look for if one variable will cancel. As it is written, so that means it has the same number with the opposite sign. We're going to draw a line and go ahead and cancel the variable out. If not, then we need to transform one or both of the equations by multiplying all parts by a factor that will cause one of the variables to cancel. So then we're going to draw our line under it, cancel out, and start solving from there. Alright, the result is an equation that only has one variable, so we're going to solve for this equation. Or we're going to solve this equation for the variable. When the value of the variable is found, we're going to substitute it or plug it into one of the original and solve for the other variable. So we're going to write our solution again in point form, so our xy coordinate, and check our solutions for reasonableness. Alright, so in our first example, we have negative 2x plus y equals negative 2. 3x minus 2y is equal to 4. So we first want to check to see if we're all lined up. So here I have x's, here I have y's, here I have constants. So we are good on that first step. So we need to look and see if anything will cancel out. Do we have any of the same numbers with opposite signs? So we have a negative 2 and a 3. That's not going to cancel. We have a 1 and a negative 2. That won't cancel. Alright, so we need to multiply something. So the easiest thing to look for is if we have a number by itself. So here we just have y. So what can I multiply y by to get the opposite of negative 2? Well, that's just going to be a 2. So I'm going to multiply this whole top equation by 2. So now I have negative 4x plus 2y equals negative 4. And I'm just going to rewrite that second equation down, layering it on Again, lining up my variables and my constants. So now just start to solve it. So we're going to take negative 4x plus 3x, and that's going to leave me with a negative x. 2x minus 2y, that gives me a 0. Negative 4 plus 4, that also gives me a 0, but we're going to write that one down because it's the only thing on that side of the equal sign. So we have negative x is equal to 0. So get x completely by itself, we need to divide by negative 1. But 0 divided by negative 1 is still just 0. So our x term is 0. And then we want to take and plug that back into one of our original equations. It doesn't matter which one you choose. I'm going to go with the top one. So I have negative 2 times 0 plus y is equal to negative 2. Negative 2 times 0 is 0. So I'm not going to write that down. So we have y equals negative 2. So we're going to write that as an ordered pair. X is first, y is second. So 0, 2 is my ordered pair. All right, on this next one, we want to look and see, again, are we lined up? So our x's and our y's do not line up with each other. So rewrite it so they do. We're going to take that top equation and move it. 4x plus y is equal to 10. We're going to leave that bottom equation alone. 6x minus y is equal to 20. So now my x's are lined up. We're going to look and see, does anything cancel out? 4x and 6x, that's not y and negative y. So we have 1 and a negative 1. That will. So we don't need to do anything else to this other than to start solving. So 4x plus 6y is 10x. Our y's are going to cancel out. 10 plus 20 is 30. Solve for x, so divide by 10. X is equal to 3. Again, pick one of the original equations, plug that x in. So I'm going to plug it into the top. Y plus 4 times 0, or not 4 times 0, 4 times 3 is equal to 10. So y plus 12 is equal to 10. Get the y by itself, so subtract 12 from both sides. We get y equals negative 2. So our ordered pair on this one is 3, negative 2. All right, again, we're going to just take a quick look at these special cases. So step 1, we are all lined up. We have our x's on top, our y's, and our numbers all together. We do not have anything that will cancel out yet, so we need to multiply. So how would I get 1 to cancel out with a 2? I would need to take and multiply that whole top by negative 2. So we get negative 2x plus 4y is equal to negative 6. Write that second equation down. 2x minus 4y is equal to 6. So now when we look at this, negative 2x plus 2x is going to give me a 0. 4y minus 4y also gives me 0. So I'm just going to write a 0 on that left-hand side. Negative 6 plus 6 gives me a 0. So does 0 equal 0? Yes, it does. And if you remember from a minute ago, if we end up with a true statement when our variables cancel out, that means we have the same line, so we have infinite solutions. All right, on our next problem, we're going to look to see we're all lined up. X's, Y's, and numbers are all together. We do not have anything that will cancel out. This time we're looking for something to cancel out negative 1 with 2. So we're going to want that to be a negative 2 on the top, so we just need to multiply that top by 2. So we get negative 2x plus 4y equals 6. And we leave that bottom part the same. 2x minus 4y equals 3. All right, canceling out, we get negative 2x plus 2x gives me a 0. 4y minus 4y gives me a 0. 6 plus 3 gives me 9. This is not true. 0 does not equal 9. So just like earlier, if we cancel out our variables and we get a not true statement, we have no solution. All right, take a minute, pause the video, answer the questions below, and see if you get the same answers that I do. Alright, so this is what you should have come up with. If you did not get this, ask any questions or go back over your work and see if you have a mistake somewhere. Alright, if you have any questions about solving systems of equations algebraically, please let me know. I will be happy to help.